welcome everyone. Let's give just a few more minutes. Not minute, maybe half a minute. Okay, welcome. Thanks for coming. Thanks for joining us. All right, let's get started. Good morning, good afternoon, good evening, everyone. My name is Jawoo, a Senior Research Fellow at IFPRI, and it's my great pleasure to welcome you to today's webinar. Today's topic is how can we improve food security monitoring in conflict-affected regions, machine learning for spatially granular food security monitoring. Food security mapping. This is the sixth event in the webinar series on IFPRI modeling systems, informing future pathways and priorities for agri-food systems. This series is intended to provide an overview of some of the tools we use to look at various aspects of the future of food systems. In recent years, Foresight researchers at IFPRI and across the broader modeling community out there have increasingly integrated data science approaches into their work. Use cases at IFPRI include applying machine learning to estimate crop production, developing risk profiles in economic modeling, using computer vision for assessing risk, and employing natural language processing for enhancing stakeholder communications and advisory services. My research background myself is crop modeling, and even in crop modeling area recent years, there has been a lot of effort to also combining data science approaches into traditional process-based modeling. And this kind of new approaches really accelerate the rate of research to help us process better data at predict more accurate status of the agri-food system. So has been a lot of innovations in this area in recent years. Additionally, also understanding how to use AI and machine learning tools responsibly and ethically has also become a critical area of research. So today's webinar, our presenters will showcase how they applied machine learning to satellite remote sensing data and combine with household survey data to estimate food security during the period of political instability and conflict. We hope this seminar will inspire you to explore similar approaches in your own work and address any challenges in your kind of data processing or analysis or whichever you have difficulties of advancing your research in traditional way. Maybe there are other ways, similar other ways that you can explore in your own way. So yeah, we hope this kind of conversation also after the seminar can spark some new ideas for leveraging AI in food systems research more broadly. So feel free to share with your ideas and ask questions, and we can have very interesting discussion after the webinar as well. Okay, so now it's my pleasure to introduce our two speakers. Jawoo is Senior Research GIS Coordinator at the Foresight and Policy Modeling Unit at IFPRI. And Joanna van Asselt is Associate Research Fellow at Development Strategies and Governance Unit at IFPRI. Before I hand over to Joanna for the presentation, I want to share a few notes on how we will proceed today. The presentation will last for about 25 to 30 minutes, with the rest of the time dedicated to questions and answers and any discussion we might want to have. Please feel free to send your questions via the Q&A window at any time during the webinar, and we will do our best to answer as many as the time allows. When you ask questions, please also let us know who you are, where you are from, and what organization you represent. And finally, we are recording this webinar and we'll make it available on our website shortly after the live event. So with that, over to you, Joanna. We will look forward to your presentation. Thanks.
Great. All right, good morning, everyone. So today, Joe and I are going to present our machine learning model that predicts food consumption scores at a spatially granular level. Next slide. So the number of fatalities from conflicts, as well as the number of nations struggling with violent conflict, are currently as high as they were directly after the fall of the Soviet Union. With the number of shocks increasing, including COVID-19, extreme weather events, and of course other household level shocks, there has been stagnation, if not even a reversal of development and economic growth in many regions of the world. In 2024, aid budgets were already underfunded, leaving many people in need without critical assistance. Given the new political climate, the situation is likely going to worsen in 2025. So it is in this difficult context that we really need a precise tracking to ensure that limited resources reach those most in need. To do this, we have developed a machine learning-based approach to estimate food consumption scores at a granular village tract level in Myanmar. We do this by leveraging multiple data sources: phone survey data, Earth observation data, crowdsourced data, and GIS data to generate spatially explicit and near real-time food consumption scores. Next slide. So we test our model using Myanmar, a country of 57 million diverse people. So Myanmar is often cited as having the world's longest running civil war. It has experienced continuous internal conflict since World War II. But after a brief period of democracy, a military takeover in February 2021, that red line, plunged the country back into war. And as shown in this figure, the number of fatalities surged dramatically following the coup in 2021. This conflict has led to economic collapse, mass migration and displacement, and widespread poverty in Myanmar. Next slide. So to monitor welfare in this challenging context, we implemented the Myanmar Household Welfare Survey starting in December 2021. For our machine learning model, we leveraged 5 rounds of the Myanmar Household Welfare Survey, shown here. So MHWS, as we call it, is a quasi-panel phone survey designed to be representative at the national, state, region levels. The first 3 rounds have around 12,000 observations, shown in the orange dots, and the later 2 around 13,000. Next slide. So MHWS is designed to have a sample size that is relative to the population of each state and region and township. So the state and regions are shown in the map on the left and the townships in the middle. So as you can see from the middle map of the townships, MHWS has coverage in 314 out of 330 townships. At the smaller administrative unit, the village tract, we have data from over 3,000 village tracts out of 14,000. And we use this unit, the village tract, as our unit for analysis for our model. Next slide. So in the model framework, the dependent variable is the food consumption score, which we measure in the Myanmar Household Welfare Survey. The food consumption score is an index that was developed by the World Food Program and is still a key component of WFP's food security classification methodology. So the food consumption score aggregates household level data on the diversity and frequency of 8 food groups consumed over the previous 7 days. You can see the 8 food groups here. And then it is weighted according to the relative nutritional value of the food groups. So this table shows the inputs of the food consumption score, the average score by round, and at the bottom here, the percentage of people with acceptable, borderline, and poor food consumption. As you can see in round 5, so the 5th round of MHWS, around 18% of the sample had borderline or poor food consumption. Over to you, Joe. Next slide.
Yes, thank you, Joanna and Jawoo for the introduction. I think, as Joanna mentioned, in the conflict affect regions like Myanmar, conducting in-person surveys is hard due to the security concerns and limited access. So in this study, we use machine learning, but one thing we want to emphasize is we rely only on public available data sets for this practice because we want to make sure that our approach is scalable and replicable in other regions. We use Myanmar as a case study to testing our approach. Specifically, the slides here shows the majority of the data sets we use. Joanna briefly mentioned, so we use remote sensing data such as climate data and vegetable index and those additional attributes like mean maximum of these. And additionally, we add quite a lot of thoughts into developing the spatial data using the crowdsourcing like OpenStreetMap and Eclipse datasets. Those datasets we think it will be benefit in improve the performance of the model. Lastly, we also develop our accessibility model for the GIS variables because a lot of the locations like financial locations are point-based data. It's hard to use by machine learning. So we basically develop access to each of the destination locations we are interested in, for example, distance to school, distance to educational facilities, and financial service. And for this measurement, we use two distance measurements. One is the Ukrainian distance, which basically the straight line distance based on the location. And the other one, we use travel time estimates, estimate the travel time from the any households and to the destinate service locations. In that way, we think these combined data set will be improved the model performance. Another thing I want to emphasize is when we develop these variables, we do put a lot of thoughts and literature reviews and also talking with the country expertise. For example, one thing we learned from the literature and a local expert is that the trade between countries with Myanmar is quite important. So in that way, we developed the variables travel time or travel time to the border countries, and in that way we capture these variations cross space. One of the key variables is the conflict data as the context of the country. We believe the conflict is a major factor influencing food security. We use the Eclipse data, the armed conflict location and the event data project as our main input to measure the conflicts. The data originally come into the Excel spreadsheet with latitude longitude, so they are point-based data. It's, in order to use it to generate the conflict surface, so we developed this density map using the GIS functions. So in each of the locations, we have a measurement of the density of the conflicts. And four variables we are interested in for this practice. One is the conflict events and fatality with minor incidents and the strategy development conflicts. For data merging, there we have two types of data. One is not time series, just one time like elevation, slope, and travel times. So for these, we just link the data between the food security consumptions and the GIS data based on the georeference coordinates and latitude longitude. And at the village track level, this which is our the study units. And for the time series data, because we do think that the month previous the survey time also affects the food security conditions. So we basically using the preceding months or preceding 3 months as the total measurement. So not only the survey time of the time series data are captured, but also we roll preceding months by 3 months. So if it's monthly data, we use here N0 means the months of the survey time, and N1, N2, N3 we means the 3 months before. If it's a 16 composite, for example, the NDVI or EVI, we use about 5 time periods to cover the 3 months. measurements. As always arguing that the machine learning model are often treated as a black box because they handle very complex and nonlinear relationship. Some studies argue like as long as the data is big enough, the model can successfully learn the underlying patterns. However, in our case, we tested that and we test basically all the available machine learning models from the simplified stepwise linear regression to tree-based regression. If we just dump the data and with the labeling reference, the model doesn't perform very well. As you can see on the right-hand side, the R-square, no matter how we do it, the R-square is pretty low. Another thing is that we test also that how do we partition the training data and testing data sets, because we have a relatively small data sets and the manual partition into like 70% for training, 30% for validation or testing. It doesn't work. And so we use the cross-validation for this practice, and we have some more details in the following slides. But here the main point is like simply dump the data to the model. It doesn't work. So first step, we clean the data as what everybody was doing, and one thing is to remove the unreasonable values, and also we normalize the data so the unit doesn't affect the prediction. We also remove the high correlated variables and also the repeating values if the 25 quintile and 70% quintile of the data have the similar values or same values. We remove these correlation variable, only keep one for the model prediction. Here we are talking about the cross validation we introduced. So at the beginning, we use a random division for the cross validation. So for the people who don't know the cross validations are, it's basically partition the data into number of folds, and then the model take in our case, we partition into 10 folds. So the model take one fold as validation and set it aside, and then using the remaining 9 folds as a training data set, and then iterate 10 times. So every fold can be used as a one time for the validation and 9 times for the training data sets. And this is very productive in terms of the smaller data sets in our case. But we found out like we just simply random division the data into 10-fold. The model doesn't perform very well because the imbalanced distribution between the training data set and the validation data set. So we apply these stratified k-fold training data sets and division. In that way, we can have better distribution among the we can have similar distribution among the testing and training data sets. So on the map on the left, the 2 columns shows the random division. As you can see, although the distribution are close, but they are not. We still have out of range values between the 2 data sets. And after the stratified k-fold conservation is applied, the data are more distribution of the training and the testing data are more close to each other. One thing when we look at the data for the food consumption score from the phone surveys, one thing we identified is a lot of the not a lot, some of the village tracks we only have received 1 phone calls, and basically we have 1 observation for representing the whole village tracks, which is really a big issue for the model performance and the reliability. So we're testing out like how many phone calls are necessary to represent the whole village tracks, so the model can perform relatively reliable. So on the map on the right, basically showing we filter out the village tracks only have 1 phone calls, 2 phone calls, and 3 phone calls. As you can see, once we have 3 or more phone calls for the village tracks, the model perform relatively stable and better So this is the data cleaning we are doing. So we remove the village tracks, only receive 2 or 3 phone calls. Here is the result, as you can see on the left. So once we did, we put a lot of thoughts for the data and cleaned the data set, the model performed much better than previously. The third column, basically the cross-validation model we rerun, and the model predicts relatively stable across each of the fold and from 1 to 10. And in overall, we have R-square values around 0.5, and the map on the right shows the scatter plot of the training data sets and testing data sets. As you can see, the training data set, of course, is performed much better because they are using to develop the model, but the model generally okay to predict the food consumption scores at the village track level. And we also take quite a lot of, when we fine tune the models, we also take into account the overfitting and issues with the typical machine learning applications. So eventually for the model, the highest R-square we got from the cross validation is about 0.555. Which is providing a promising result for the model application. So this is the final result we have for the prediction, and the map A on the far left shows the survey we actually have from the village track level. As you can see, they are highly correlated with the population distribution, but also one thing you notice, we have only limited area, as Joanna's slide shows before. About 3,000 village tracks are covered by the phone surveys. The large area, especially for the area with less population densities, are not covered entirely by the survey. So our model can predict in the map B in the middle, can predict food consumption scores for all the village tracks, and it shows quite interesting results. Strong heterogeneity across space in terms of food consumption scores, and even for the village or state better off, still there's a severe food security issues in the village track level. And also I want to emphasize last thing we also practice these models to forecast in addition to the spatial interpretation to estimate the food consumption scores for the area we are not conducting phone surveys, but also more useful, we want to implement that for the forecasting practice. So we update the underlying data to the recent in-season time period, and also predicts how the food consumption scores changing over time. And our preliminary results align with the phone surveys subsequently provided later on, which is provide a timely estimate of in the future practice. This slide is basically showing not just the results, also we want to invest in which variables are more influenceable in terms of prediction. It's help us interpret the model behaviors and also offer more insights for the policymakers when addressing food security issues. As you can see, the rainfall data, of course, for both the survey time and also the previous months, are strong factors to the food consumption prediction. However, I also want to emphasize, besides the remote sensing data, data sets like travel time to the airport, which is
Did we lose Joe? Hello?
Yeah, I think we may have lost Joe.
Oh, sorry. Okay. Joanna, do you?
Yeah, I can talk,
have
but the
the line?
problem is
Okay.
he's controlling the slides, unfortunately.
Okay.
So,
John, why don't you just talk about the predictor? Yeah. Or you want me?
Okay, let me try to find the slide deck from my side. But Joanna, do you have some comment or something to discuss on this?
sure. I mean, I think Joe was almost done, so I mean, I can basically just finish. So we were talking, he was just talking about the importance of the predictors. And one thing that we did find is that the Asselt conflict data, so it's not just the geographic data that it's typical that you put into the model, but it's also these GIS data that we found was very important, such as the travel time data, as well as the conflict data that we is open source data from Asselt. And then as well as, the different travel time variables and a lot of data that had to do with productivity and land use. So next slide. Yeah. So, I mean, that's basically the end of our presentation. We just wanted to showcase the work that we did in terms of using this model to predict food consumption scores. And I think what's really important to take away is that what we did is we used an open source welfare survey. So basically a survey that's publicly available online. And we use conflict data that's publicly available. And of course, all this georeference data that's all publicly available. So basically the model is all taking different sources of publicly available data and pulling it together in a machine learning model to predict food security in a conflict affected environment. So this is, I think, a very powerful tool to do these real-time predictions. And there's a lot that we still have to do. The next step we really want to, and Joe started talking about it, is forecasting. So right now we're using the model just to predict the food consumption scores in the village tracts where we don't have data. However, what we would like to do, and we started doing, is using the model to forecast food consumption scores in conflict affected areas. That way, what you could do with the model is you would be able to say something about what's going to happen next. The other thing we want to do is start to implement some deep learning techniques in our machine learning. And also we have ideas about bringing in other also openly available variables. Yeah. So that's our conclusion. So maybe we'll turn it over to discussion.
Yeah, let's do that. I still don't see Joe. So yeah, maybe let's
Hi,
start.
Joe, can you hear me?
Oh yeah, I hear you.
Sorry,
Sure.
my computer crashed during the presentation, so I use Liang's machine now,
Oh,
but
I
the
see.
camera cannot be turned on somehow.
Chris, let you talk.
Okay. So Joe, do you want to add anything as a concluding remark?
Okay, sorry, I apologize about that. I don't know. No, I think Joanna present pretty well, and the only thing I want to add is so right now we are working on the time. So we already demonstrate our prediction across space to basically have predictions of the area we don't have surveys. Now we are working on try to forecast the in season, the food consumption scores, which is probably going to be more practical use by the team. Yeah.
Okay, great. Yeah, thanks so much. Thanks so much for the presentation, Joanna and Joe. All right. So let's get into the Q&A part of the seminar. So yeah, all the audience, please enter your question into the Q&A box. So you will find the Q&A icon under the, the taskbar. So yeah, please use that Q&A box to enter your question. So I have a couple of questions already. Oh yeah, and I see some of the audience also raised a hand on the chat. So let's go through the questions we already have have been asked, and yeah, let's see if we can find time to also open up like microphone for you to join. But okay, good. So first to Joanna, again, thanks so much for the presentation. You emphasize the importance of using open access, open source data, incorporating in this analysis. However, in the conflict regions, I mean, some of the data, like rainfall data, probably are not necessarily affected by conflict. But for example, travel time and some of the other data, do you see there might be some influence of conflict and migration patterns and things that might introduce some biases in this open source data, so that might also making it very difficult to incorporate this kind of the analysis, time series analysis?
Yeah, that's a really good question. So thus far, that hasn't necessarily been an issue for us. First, we're using a lot of data that's taken over time, right? So if you think about rainfall, it's over the season. So we're averaging it over a period. So yes, I mean, especially in Myanmar, there are blackouts from conflict. So during certain periods, we won't have certain data, but because we're averaging that over 6 months, I think that's actually okay. And we have seen that despite a lot of electricity blackouts and whole areas without internet, that actually this data is still there. The one issue, of course, is the phone survey that we're using. So in a lot of conflict areas, that doesn't exist, right? So it's really a tool that needs to be used if there is also household level data being collected. And that's why, it's really a tool that can be put in place if there's a bigger household survey. Without that data, yeah, it's obviously hard to run the model.
Actually, related to that, several other countries are also experiencing conflict at the moment. So what do you see as the most important factors and steps, perhaps, for applying similar approaches in those contexts? What are the kind of key prerequisites, and under what condition might this approach work or not?
Yeah, that's a good question. So I think one thing that we have in Myanmar is this Myanmar Household Welfare Survey. And that what we have is a lot of data. So which enables us to really have a large amount of observations at a small level, right? So the wider spread the data is, and the more observations within one small geographic unit, then we have better ability to run the model, right? So that's the first thing. The second thing is this, we need Earth observation data for the country. We would need, ACLED data is there for all the countries. And then there is a lot of open source data that's there now for a lot of places. And so I really think this is something that could be done in different countries if we have the dependent variables. So that, of course, depends on having a welfare survey or an integrated household survey. Yeah.
Right. Okay, one more question to Joanna. So can you share any feedback from stakeholders, particularly, I guess, policymakers, on the research findings? And specifically, have there been any sensitivities around sharing or publishing this analysis during the ongoing conflict?
Yeah, so actually for us working specifically on this country, we have said that we are not going to share or talk really about our results just because of the sensitivity of the situation and how important it is to do this food security analysis. So I'm sorry, I can't really talk about it, but yeah, it hopefully will be an important exercise.
Yeah, I totally understand. Okay, good. Then yeah, let's move over to Joe. So we have a couple of technical questions. One question is about this R-square value that you showed. In a way, you also kind of discussed it briefly. So we noticed you had quite a low R-square in one of the slides in the table. So yeah, so can you tell us a little bit more about how do you address it and how do you actually take it forward to make reliable prediction?
Yeah, I think that's a very good question. And actually, we do spend, although in the presentation we spend just 2 slides, but we do spend quite a lot of time to cleaning the data. So as I mentioned in the slides, the whole point is to dump the data and allow the machine learning to learn. At least for our case, in this limited about 3,000 value tracks for each round, it doesn't work. What we found is that if you better understand the data you have and then you have a better chance to make the prediction work. And I think for the typical machine learning applications, the normalization and the outlier removal, that's necessary for this practice. But also what we, in this special case, we found like we need for each value track, we need a certain amount of the observations to represent a value track in order to have the reliable and the stable prediction for the model. I think I mean, in general way, like if you have more data, the model perform better. Yeah.
Okay, and another question is around about one of the last slide kind of bullet point mentioned deep learning as a next kind of approach, next step. So can you tell us a little bit more about it? What specific deep learning techniques or architecture do you intend to use in the future research?
Yeah, I think because nowadays the neural network in general have better performance compared to other machine learning like random forest and other sport vector machine, for example. But the computation time also is a big factor. For our next practice, I think because this is a really track-based analysis, so we couldn't have do the the segmentation part, like which is what are the neighbor really track looks like, and also the time dimension we couldn't add. So we will implement the deep learning, especially there's a high resolution, for example, high resolution infrastructure data and Google Maps and land use maps are available. And those informations we couldn't use it fully as of the prediction in the model because we don't have the deep learning components. I think we will develop the chips like the small area around the value tracks to improve the model performance.
Okay. And another question just came in is asking very critical question around the interpretability of machine learning models. Yeah, as you mentioned, there are a little bit of black box kind of thing. So you have lots of data. You have a lot of data, and then of course you have better kind of explainability, and you can also apply different kind of more traditional approaches. But yeah, in your case, there are lots of challenges that you wanted to address using machine learning approach. Can you tell us a little bit about the structure and interpretability of this machine learning approach, and whether that has any handicap compared to other traditional, more statistical approaches like OLS?
Yeah, from my point of view, I would think machine learning is a not very good tool for the inference, analysis, but more for prediction. They are more reliable in prediction. But I do think the machine learning is not replacing, for example, econometric analysis. It's more like complement each other. And for example, for this study, Joanna was doing quite a lot of econometric analysis to identify, okay, which are the potential factors that are more useful. And then we derive these and the predict variable into the model. And also in terms of interpretability, but also it's evolving quickly for the machine learning approach, and they have more package and more functions to derive, like besides the important scores, also other variables. For example, you can tell the directions, how they influence, and we will implement that in the analysis also. I think we will see more and more, interpretability functions provided by the machine learning, even though there are still black box. Nobody knows how these parameters work in the machine, but we will identify more, informations from the new package released, I think.
And then maybe Joanna, did you also have any comment on this question as a economist yourself?
Sure. Yeah. I mean, as Joe said, we did use OLS models to help us understand. Instead of throwing all the data in, we helped us identify what we thought would be key variables in the analysis. I do think this is the prediction aspect of our model is not something that you could do with OLS analysis, and I think that what it's doing is a very useful exercise, and the relative food consumption scores that we get from the model, they're very there's a lot of variance in them, and it's really interesting to then take those predicted food consumption scores. One thing that we've done is then, okay, we've predicted the food consumption scores, or we forecasted them, and then we take our next round of data and we look at how accurate these results were, and it's really been a very interesting exercise in that way. Yeah. So yeah.
Okay, good. Speaking of which, can you tell us a little bit more about food consumption scores? Especially, is this, as one of the question mentioned, is it same as small area estimation in a way?
Wait, if it's the same as, can you say that again?
The small area estimation?
No, I mean, the food consumption score is just this index of the 8 food groups that basically it's a number, right? So I think the average number in Myanmar in round 5 was 62, right? So it's a number that we add up from the diversity of food consumption and the amount of food consumption. So it's basically an indicator of diversity and frequency of food consumption, which is an indicator of nutrition in the country, right? So this is what we've chosen to use as our dependent variable. The thing is, because we have a telephone survey, the amount of data that we can collect is limited, because we're calling people by phone in obviously a pretty unsafe environment. We don't want to take too much time. So we can't implement a full consumption module. So what we've chosen to do is to use this food consumption score. So that's what we can use in our model. So Joe and I haven't done this yet, but we've talked about it, is that we also have other indicators, different dietary indicators like dietary diversity, that we could then try and use in our model and see how well the model can predict other types of consumption and nutrition indicators. So that's also a next step. Yeah.
Okay, one more question on the data, maybe to Joe this time. So does the conflict affect travel time, especially during the period of unrest? And for example, would travel time will be lengthened, or because travel might be restricted, and resulting in increased travel time across conflict-affected regions? So yeah, the question is asking basically whether you took that into account when you're developing this data set.
No, I think because the travel time is more provide a baseline, like how far in terms of travel time in a normal time, like and in considering infrastructure and the media, how much time it used to travel to the destination, and the conflict data is independent, I think, from that analysis. I mean, we would love to have, if we have that information, but just for the model perspective, to model travel time, taking into account the almost a real-time effect of the conflicts, it's hard. I think that's probably deserve another topic itself. Yeah.
Okay, yeah, there might be one of the future research, more foresight kind of scenario, maybe scenario analysis. Okay, and a little bit more broad question on the kind of modeling framework itself. So now that you have the basic model in place and you showed us the result today, so how long would it take for you to update the model to be able to run it after each survey, so that it can be more systematically kind of assessing over time, and how this can be something more near real time, or not necessarily real time, so more frequently, to give more monitoring power and also more better predictability or forecasting value for policymakers, etc.
Yeah, that's the thing I think Joanna and I was working on, and in the next phase we really want to do is that prediction, I mean, over time, like how is the food consumption score change over time, and like you said, in the not real time, but near real time, because for the data we use, the satellite data right now, the release lag time is around like a week or 5 days. So we do have the access to the almost like near real time of the satellite data. But that's also present another bottleneck, like do we have enough time series data sets? I think right now we are talking about, Joanna and I, we are talking about to add more like market price data, which is a strong factor of the food security. And those data do exist at different resolutions, and we need to have think about it to have a systematic way to implement that in the model. But in terms of the model running time, I think as I mentioned in the last slides, we did a practice to forecasting the food consumption scores in the like before the survey was conducted, or while the phone survey was conducting in the field. So and then try to validate our results, and it's performed quite well, I would say. And I like any machine learning models. Once the model was developed and and then just to update the underlying data to predict the near future or the near real time, it shouldn't be a bottleneck in terms of the running time. It's more like how long, what data we have, and also we cannot just predict out of samples, and we need to be very careful when we make a prediction. Make sure we are validate, not fully validate, but at least partially validate when we predict the near future food consumption scores or other food security issues.
Okay. Okay, then maybe one more question to Joanna. So yeah, you mentioned the difficulty of sharing or publishing this kind of analysis in very politically sensitive environment in Myanmar. So what is next for you? I mean, as a researcher, do they have anything like publication plan, or how do you want to take it forward without really within this constrained kind of environment?
Yeah, that's a good question. So I think we do plan to publish the model that we've developed, but we have, and also in this presentation, as you've probably noticed, put limited emphasis on the results. We haven't really discussed the context, right? We've just shown that we've run the model for this context, and what the model can do, but without really going into the results. So that's how we've also position the paper. Of course, that's a little bit hard to do. I mean, we would like to move forward and I do all of these things we talked about. And of course, this is something that we can do within the community, right? And then at that point, we would have to figure out how to publish that. But I think, again, what we're focusing on is publishing the methodology rather than the results. Yeah.
Okay, yeah, that makes sense. Okay, great. All right. And okay, I just saw another message from Abu Bakr Hema from our Dakar office, kind of mentioning, I really appreciated your presentation, and yeah, that they are also working on something similar approach, and they'd love to share with you another presentation. So yeah, please follow up with Joanna and Joe directly, Abu Bakr. All right, great. So I don't see any more questions. So maybe I will give you like final remark, Joanna and Joe. Yeah, if you have anything to share with the audience today, I would appreciate.
Okay, I can. I think
Yeah.
to me, the machine learning is it's a very promising way to do this type of analysis, and I would see besides the phone surveys, like I think one of the question was raising, so we want to maybe link. Right now, we are working with the other country programs also, like try to, for example, using the LSMS surveys to predict the poverty or farmer topology, that kind of applications. I think as more, especially nowadays, almost all the surveys or household surveys have the GPS locations, and we would like to take these opportunities to expand our analysis for application of machine learning and deep learning and even the large language models then for this type of analysis and in the future. Yeah.
maybe to end with my final remark, just I want to emphasize maybe a huge advantage of the model that we found, which was just when we do most of our analysis and descriptive statistics in general, we usually present, for example, if we're talking about the food consumption score at the state region level, so at a very high geographic level. And then there's these whole areas that are basically excluded from maybe what we categorize as having low food consumption scores, because overall in that state, there are people pretty well off, right? But what we really found in terms of our results is that there, within those kind of better off regions, there are these huge clusters of village tracts with very low food consumption scores, right? So this is something that if we were doing a normal descriptive table, we wouldn't see those spatial patterns. The other spatial patterns that we see that are very important is that, you know, when we take the averages at the state region level, which we all do, you know, there's so much cross-border clusters of food insecurity, right? So instead of targeting a state, which would normally be done, you want to target a region across states. So I think this is something that the model does a really good job of showing these spatial patterns of low food consumption across the country. And I think that's really something that's, you know, very important and very needed right now.
Actually, I just saw one last question just asked by James about training or kind of, I guess, capacity building opportunities modeling. And I guess, if I may, maybe this is where the use of all the open access data. Is the Myanmar household survey data also like open access? Is it something?
Open access.
Okay,
Yeah.
Great. So James, if I may, so all the data the presented and analyzed in this study is open access, and once the paper is published, maybe you can follow the methodology, and maybe that will be a good also training opportunity for yourself. But I mean, is there anything else you want to add where people can find, you know, more training opportunities to raise more capacity on kind of incorporating this kind of machine learning approach in economic analysis?
There's many resources. Like I would say GitHub is the home for everything. And
Yeah.
but for these studies, I think our paper is under review right now. And once it's publicly available, we should be able to share more. And the model, even the model itself, I think we can package the model and the code, so the users and the people, the researchers who are interested in this can have a look at that, and maybe they can implement in their own studies.
Oh yeah, that'd be wonderful. So you will also make the code. Yeah, you have used open access.
So that's the whole goal.
Perfect.
We want to make these as more scalable and replicable for different countries, and the code, the input data, and it all even the model itself will package into binary files so people can use it for their studies.
Excellent. Great. All right. So yeah, with that, maybe we can wrap up the webinar today. Thanks so much for sharing this very innovative approach today, Joanna and Joe. And good luck for your publication. We're very much looking forward to the publication coming out soon. And yeah, also thanks everyone for asking very thoughtful questions, and hope this was useful for you to also understand and get a little bit inspired to incorporate similar approaches in your own research area, respectively. So yeah, thanks so much, and we will see you at the next modeling series webinar at IFPRI.